Welcome to this brief Brewlab overview demonstrating the procedures involved in isolating wild yeasts from environmental sources. The target of this is to obtain yeasts which can be used safely in brewing and beverage production and which are not contaminated with bacteria or moulds. We will be using laboratory facilities in this demonstration, but the same procedures can be applied to use at home or other locations. We will emphasise the value of using a microscope to view the organisms we isolate, as this helps to see the range of microorganisms present and to select the best candidates for use. We will also illustrate the selection and culturing procedures used to ensure that we obtain pure cultures, as this is important to avoid hazardous microbes and to maintain long-term quality control. We'll look to end up with storage cultures such as these, which we can use to prepare working cultures for fermenting. So here's an example of some fruit which would have on it some probably wild yeasts, a mixture of bacteria, maybe moulds, which we could select as useful sources. Here though is an example of ones that we don't want to select, ones which have got significant mould growth, because they will be very difficult to select anything else out of that in the processing. And here's some of the fruit that we can take from a little bit dried from a tree, but we could also use flowers such as this, because the nectar in the flowers would be supporting yeast growth, or possibly bark or insects even. So when we're doing the isolation, we want a clean environment. So here we are in the laboratory. We've got a fairly clean laboratory bench. We won't want too much clutter around. We don't want sort of drafts and anything which would bring microorganisms in to contaminate our working. But that bench, we can't quite guarantee that it's going to be absolutely perfect. So we do want to do a disinfection of that surface with a bit of disinfectant to swab it. We'll be quite generous with this, not only because it'll give us a contact disinfection, but it'll also create a vapour phase above the surface, and that vapour phase will tend to give us a little bit more aseptic conditions as we're working. We'll also use a Bunsen burner, and you could use a camping gas burner or something, any flame which would be controllable and allow us to not just burn off possible contamination on the surfaces of things, but it also creates a working environment which is aseptic in the near surroundings, and the air will be drawn into the flame and it'll be brought up and sterilised, and it'll create a convection current around it. So that's a useful environment to be working in. We can open our sample tubes and so on locally to that and be fairly assured that there won't be too much contamination. So here we are with our sample in a clean container. We will use a number of instruments in order to help us isolate the yeasts. We've got sterile scalpel. Now that's pre-prepared, but you could use a sharp knife or a scalpel itself and flame it to sterilise the surface of it. We're also using media, so in this case we've got malt broth, which is a low concentration of sugar in extract from malt, but you could quite easily use a wort that's been prepared and well boiled, or autoclaved in a pressure cooker in order to sterilise it. So we're going to transfer a small sample from that fruit to the tube. We're going to allow it to grow for a few days, and we're going to view what's grown in it. We're going to have an idea of what might be present in there. We're going to use some tweezers here, which have been pre-sterilised again, and that will help us hold the sample so that we can cut an appropriate part of it. Now, in a sense, this is where we want to be clean ourselves, because we could contaminate the sample. We want to make sure we've washed hands beforehand, and we're not providing a shower of material from our clothes or hair. So a lab coat's good, but just general cleanliness is important. And we're going to take a small amount of that sample there and insert it into the tube. Now in this case I'm going to flame the surface of the tube, and that's going to be important so as to keep control of anything that might be contaminating on the surface there. Flame it again and put the top back on. So that's now going to go and be incubated at 20 degrees. Room temperature will be fine for a few days. I've also taken a sample here to view in the microscope, so just macerating that up, cutting it finely, and then we'll put a drop of water on that slide. I'm going to put a cover slip on the top, and that cover slip will give us a smooth space in order to get a clear view in the microscope. I'm just pressing that down so as to disperse the sample. And we're going to use this microscope. You don't need anything terribly sophisticated. Your target is about a 400 magnification. So a 40 times objective would be fine, and a 10 times eyepiece would give us the right combination. And we're going to get a general view of what's in there, and on that screen there we can just see a lot of debris. It's hard to see any yeast or microbes there at the moment, but in the future presentation we'll go through what we are looking for. Here's an example of some of the yeast that we can see with a few bacteria in the background, and in the long run we're aiming to isolate those, purify them and keep them on a storage stock. So that's the intention in the target, and we'll be looking at that in a future presentation.